All right, these are the notes for 8.5 part 1, and they are called equations, reducible to quadratic. So what we're going to be looking at is we're going to need to solve some equations that are not quadratic equations, but they're set up in a way that we can think about them as quadratic equations and then solve it using quadratic formula or factoring or completing the square. Those are the 3 ways we have to solve a quadratic equation. So let me just show you an example of one first. So it's going to say something like this. Solve x to the 4th. Is that quadratic? No, a quadratic equation is ax squared plus bx plus c. A quadratic equation is in that format. Something x squared, something x, some other number. So this one has an x to the 4th in it, so we automatically are like, oh, that's not quadratic. So we might solve something like this. It's not quadratic, but we're going to be able to use the same methods that we use to solve quadratic equations to solve this one. So what we're going to do is we're going to, instead of thinking about this as it looks, we're going to think about it as if we replaced this and this, the x to the 4th and the x squared. Because really, those are the only 2 things we need to change to make this look quadratic, right? Yeah? Mm-hmm. Yeah, I guess so. But the problem is when you started, it didn't work. You know, like the fact that we can do something to both sides and it still is okay only is based on the fact that we started with something true. Yeah. That's a good question though. I like that. I like that thought. So what we're going to do here is we're going to, instead of thinking about this as x to the 4th and thinking about this as x squared, we're going to say, what if we introduce some new variable and we're going to call it u? So we're going to say, what if we think of u as equaling x squared? So anytime we see an x squared, we're going to put a u there instead. Because we want to make this look like a quadratic equation. And right now it's not quadratic and we don't know how to solve it. So wait, what would this be, Clay? This would be u squared. Do you guys see why x to the 4th, I can write it as u squared? Because u is x squared, and x to the 4th is just x squared squared. So it's just u squared. So this is u squared minus 9 what? U, because x squared is u, plus 8 equals 0. The rest of it stays the same. So now, does this look like a quadratic equation? Yeah, it does. So, how do we want to solve it? Remember, when you're solving a quadratic equation, some of you guys weren't here, we wrote this little list out. What'd you say? ABC. So when you guys are solving quadratics, who can tell me what the easiest way is as long as it actually works? Yeah? Factoring. If factoring works, we want to do it. Remember, we find 2 numbers that multiply to c and add to b. That's the easiest way if it works. Or AC method, if that worked. If that doesn't work, you might want to try that weird section we had, I think it was 8.2, completing the square, where we made that one side a perfect square trinomial so we could factor it. Now, sometimes even that is a little messy because you have weird numbers and you have to deal with fractions. So if neither of those work, what's that thing we know with the song? Yeah, we can use the quadratic formula, which always works, but it's just, I don't know, it kind of takes a little time to do it, and I think it's a little messier. If factoring works, we want to factor. So let's go through our options. Would factoring work on this one? Yes. Raise your hand if you can tell me how I can factor this one. Elise? -1 times -8, and do those add to -9? -1 and -8? Yeah. So we can do u minus 1 times u minus 8. If we FOILed that, it would FOIL back out to this. So see, that's why if you can factor, you want to factor it. Like, you wouldn't want to do quadratic formula if you didn't have to with this one. equals 0. So now, how do I figure out what u is if I know that either of these two factors are 0? 1 and 8, right? Because we want to say, what would make u minus 1 equal 0? Because if that equaled 0, this whole thing would equal 0. And what would make u minus 8 equal 0? 1 and 8. Now the problem is, we are not trying to solve for u. They wanted us to solve for x. So yeah, what we need to do is now we need to go back in and say, all right, remember how u is the same as x squared? So we need to say now x squared equals 1 and x squared equals 8. And those are easy to solve for, right? So now, how do I know what x is if x squared is 1? Yeah, we'd square root. I mean, we kind of know on this one, but we'd square root each side. So on this one, x is going to equal plus or minus 1. Good. Positive or negative 1, because if we did negative 1 and squared it, it would still equal 1. If we did positive 1 and squared it, it would equal 1. And then on this side, x equals positive or negative. We can say square root of 8. Do you think square root of 8, do you think we can simplify that at all? Yeah. Yeah, because 4 and 2 go in, and we know 4 is a perfect square. So how can I write root 8? 2 root 2. So x actually equals positive or negative 2 root 2. Right. We just want to get x itself. Good. So, since we never squared it, I'm not going to make you plug these in and check them. You would want to, probably, if you had like extra time on your test. So x equals positive or negative 1 and positive or negative, well, 2 root 2. Yeah? Well, we don't want the plus or minus to be in between the 2 and the square root of 2, because that does happen in the quadratic formula, doesn't it? But in this case, since it's just the square root of 8, it's kind of like there's a 0 out here. 0 plus or minus root 8. Good. Do you guys have any other questions on that one? We got 2 more examples to do. I made these kind of short. No, I shouldn't have made them so short. 2 more examples. All right. So our second one has slightly different instructions. The instructions are find the x-intercepts of, and then the graph is f of x equals, this is a long one, x squared minus 1 squared minus x squared minus 1 in parentheses minus 2. Getting that signature like that. Yeah, you can graph it. It would be kind of difficult to graph by hand. You're right. You can graph on a computer. Wait, do you guys want to see what it looks like with the graph? We've got time because I don't have that many notes. That's okay. I think they'll be able to see it. I can't see what I'm typing though. Let's see. Graph. What was it? X squared minus 1 squared minus x squared minus 1 minus 2. Let's see if that works. There's what it looks like. Yeah. It looks like there's like some decimals. We're probably gonna have to find. It's probably gonna be. It looks like it's gonna maybe be some weird square roots here. Maybe 0 is gonna be 1, and down here between -1 and -2, that's what it's gonna look like. Oh, this one's way zoomed out. Yeah, so it just like you can't even see this little dip in it. It's so zoomed out. But there is a, it's like you can almost see it's like dipping a little bit right there. Yeah, but we don't know exactly what number that is, and we want to be really precise. We want to be really exact. That's what it's going to look like. All right, so on this one, does anyone have an idea? We're going to use the same strategy here. Let's let u equal something so that it looks quadratic. Does anyone have an idea? Raise your hand for what we could let u equal in this case. Elise? Let's try it. Elise says let's try letting u equal x squared minus 1. So right here, this whole thing she's saying is going to be u. So this is going to be u squared. U squared. That looks good so far, right? That looks like the beginning of a quadratic. Something squared. And then what would we have? Minus u, right? This is all u, so minus u minus 2. So now if it says find the x-intercepts, what does that mean it wants us to do? What should we set it equal to? 0. We want the function to equal 0. We want like the y value to equal 0. You paying attention, Jake? If my students listen to these videos next year, they're going to be like, man, this Jake kid. All right, who has an idea for how we should try solving this quadratic? Because now it looks like a quadratic. Right now we're solving for u, yeah. You could add 2 to either side, but remember, quadratics are easier to solve if we have it equal to 0. We could move these over and try square rooting it, but if we square root this whole side, there's not much we can do. Do you guys need to use AC method here? Who can tell me why I don't need to use AC method? Yeah, Ella said there's just a 1 right here, so we don't have to use AC method. If there was like a 3 right here, you might have to use AC method. You guys are trying all the hardest ways. Elise? How about regular factoring? -2 and +1, right? Do -2 and +1, do those multiply to -2? Is -2 plus 1 -1? Yeah. So let's do normal factoring. What multiplies to -2 and adds to -1? -2 and +1. You guys, that should be your first thing that you try, right? Don't try all the harder things. Yeah, this is factoring. Yeah. No, you guys said AC method. You don't have to do AC method. That would take so much longer. So what are my two things that u equals? -1 and +2. +2 would make this equal 0, right? So u equals 2. -1 plus 1 would make this equal 0. So u equals 2 and -1. But is that what they wanted us to find? No, they don't want it. They don't care about what u is. Yeah? No. Yeah, you're always going to have to solve for x. So now what should we do to figure out what x is? Exactly. We know now that instead of u, we're thinking of that as x squared minus 1. That's what we let it equal. So we're saying x squared minus 1 equals 2, and x squared minus 1 equals -1. So now I just need to solve for x in both of these. There's a squared in it, but since there's not an x squared and an x, I can just do this normally. Now, actually, this one, we could factor it if you wanted to, or you can just solve for x normal way. What would you do to each side to get x by itself? Yeah, add 1. So x squared equals 3. Nice. So I have to square root each side, and whenever we square root each side, like Carson said, we have to put the plus minus. So x equals plus minus root 3. There's one possibility. Can I simplify the square root of 3 with a tree? No, it's just going to be 3 and 1. And then, let's see, on this one, what should I do to each side? Oh, okay. X squared equals 0. So x equals 0. Do you need to put plus minus 0? And that's good that we got that, right? Because you remember the picture of the graph? Remember, it looks like it hits at 0, so that must be that one. And the positive or negative square root of 3 must be positive square root of 3, negative square root of 3. Is the square root of 3 going to be between 1 and 2? Yeah, because 1 squared is 1. What's 2 squared? 4. Yeah, isn't that nice? That worked out nicely. So we've got, how many answers did we end up getting? How many x-intercepts? 3, right? The negative one, the 0, and the positive square root of 3. So x equals the positive or negative square root of 3 and 0. And I'm totally fine with you guys putting the plus minus. You don't have to write them separately. Oh yeah, yeah. On this one, you could write them in either order because technically this one is both bigger and smaller than that one, right? One more example. Yeah, I almost stopped right there actually, and then I thought that's gonna be really short. Alright, so we're gonna solve one more. We're solving for x. X minus 3 root x minus 4 equals 0. So, okay, this one's tricky because we want to use the u again. We want to make it look quadratic. We want to make it like something square. Charlie? So then, yeah, so if u equals square root of x, and what does u squared equal? X. Okay, let's see if Charlie's method that he just suggested works. Charlie says, let's let u equal the square root of x. So then u squared is just regular x. Does that make sense? So if u is the square root of x, if we squared this side, it made it u squared, and we squared this side, the square root and the square would kind of undo each other, right? They're inverse operations. So we just have x. So now, what can we write instead of x? U squared minus 3u, because the square root of x is u, minus 4 equals 0. Nice, I think that's going to work, Charlie, because does this look quadratic now? Yeah, this looks quadratic. So anytime you see a square root in the problem, you're going to have to use u equaling a square root of something so that you can figure out what u squared is. Normal. Okay, you guys, please help me solve this in not a difficult way. Yeah. Negative 4 and positive 1. Right? Those multiply to negative 4. Negative 4 plus 1 is negative 3. Nice. This actually might be the easiest section out of 8.1 through 8.5. It's not super easy, but it's a little simpler. Tomorrow they'll get a little more complicated. So what would u equal from this set of parentheses? 4. Because if I had 4 minus 4, that would be 0, and 0 times anything would get me 0. And what would u be from this set? Negative 1. Good. Now, is that what they wanted me to find? No. They wanted to know what x is. So what did we say u was in the beginning? The square root of x. So now, instead of what we see right here, we know that the square root of x equals either 4 or the square root of x equals negative 1. So what should I do to each side here to get x by itself? Square it. Squared, squared. So x equals 16. And on this one, square it, x equals 1. Okay, now here's the thing. Do you remember this from our last unit? Since we squared both sides to solve this, we have to check it. Yeah. No. So anytime, because we can't be lazy with checking this. Yeah, I really should. So since we squared both sides, we have to check. We don't want to be lazy with this. So we're going to plug in 16 and 1 and see if they work in our original equation. So x minus 3 root x minus 4. So let's try the x equals 16. So we've got x, which is 16, minus 3 root x, so minus 3 root 16. And then what did it say? I don't want to have to scroll back up. Minus 4? Yeah, minus 4 equals 0. That was the chalkboard. Alright, so let's check. So we've got 16 minus 3 times what? Which is? Oh, yeah, this is 3 times 4, right? Square root of 16 is 4. And 3 times 4 is 12. So we've got 16 minus 12 minus 4 equals 0. Is that true? Yeah. Yay, that worked. Okay, let's try x equals 1. So we've got x, we've got 1 minus 3 root x. So minus 3 root 1 minus 4 equals 0. What's 3 times square root of 1? 3. So we've got 1 minus 3 minus 4 equals 0. Does that work? No. If it was 1 plus 3 minus 4 equals 0, it would have worked, right? But this one doesn't work. So what's our only answer? X equals 16. Alright, those were short. Okay, so tomorrow we're doing 8.5 part 2. Wednesday and Thursday we're reviewing. You guys need to review and you need to do well on this test. You have to retake it. You have to retake it. Your homework is page 537, number 11 through 27 odd.